In the gizmo we just did, we briefly looked at Newton's 3 laws of motion, so now we're going to talk about each one. Newton's first law looks at inertia, which is a resistance to change. So an object will remain at rest or moving with a constant velocity unless acted upon by an external non-zero net force. So what does that mean? If we had our net force is equal to 0, and then there would be no change in velocity. In other words, an object at rest will stay at rest, and an object in uniform motion will stay in uniform motion as long as no unbalanced force acts on it, so no external non-zero force. So if you want to change the motion of an object, a non-zero net force must act on the object. It was Galileo who coined the term inertia, and he's the one that realized every object had inertia. So what he did is something called a thought experiment, which is a theoretical, idealized situation that can be imagined but not created in the real world. So his experiment involved a ball rolling down a slope like this. So the ball would start off here, and then he wanted to see if the ball would come up the ramp. And he compared that to a ball coming down off a level surface, and noticed that the ball would go further on the level surface. This is a thought experiment or an idealized situation because in any case the ball would eventually slow down and stop since the presence of friction is always there. Newton's second law states that when a non-zero net force acts on an object, the object accelerates in the direction of the force. The magnitude of the acceleration is directly proportional to the magnitude of the net force and inversely proportional to the mass of the object. So we know that force, or your net force, is equal to mass times acceleration. And we can now solve for your acceleration. Oh, these are also vectors. We're going to solve for acceleration. So isolating your acceleration variable, you're going to get net force divided by mass. Okay, so now it's saying that the magnitude of the acceleration is directly proportional to the net force. And what this symbol means right here just means it's directly proportional to. So in other words, if you multiply your force by a factor k, so k can be any integer, then you'll get a, your acceleration. The second part of the statement states that the acceleration is inversely proportional to your mass. So inversely proportional just means that it's the opposite relationship, so it's 1 over m. So that means that your acceleration would be equal to k over m, where k is just a factor. Since 1 Newton is defined as the net force required to accelerate a 1 kilogram object at 1 meters per second squared, k would then be equal to 1. So the equation can be written as acceleration is equal to, so we're just combining these equations, your net force over mass, or more commonly, it's net force is equal to mass times acceleration, if we rearrange the equation. Newton's first 2 laws looked at the motion of an object or a system of objects in isolation. So now we want to describe the motion of objects that are interacting. So the law states that for every action force, there's an equal and opposite reaction force. So example is if object A exerts a force on object B, then B exerts the same force on object A that's opposite in direction. So we can write that as force of A on B would be equal to the negative force of B on A. An example would be when a baseball bat strikes a baseball. The action force is a forward force that the bat is exerting on the ball, and the reaction force is the backward force that the ball exerts onto the bat. So during this collision, the ball is accelerating forward, and the bat slows down as it accelerates backwards. Okay, let's do an example. A strength competition has 2 contestants standing on either end of a train of 3 weighted train cars, and each contestant attempts to push the train toward the other. Contestant A exerts a force of 917 newtons right, while contestant B exerts a force of 1,020 newtons to the left. If the masses of the train cars are 125 kilograms, 98 kilograms, and 113 kilograms, calculate the initial acceleration of the train. So first thing, we want to write out our givens. Next step is to draw our free body diagram. So this is going to be your total mass. And then, ooh, awesome color. This is going to be your first force. This is going to be your second force. I'll make it straight. And we're going to say that this is our positive direction. So now we want to solve for acceleration. So let's start off with our equation. F is equal to ma. And since we want to solve for a, let's isolate a. So a is equal to your net force over your mass. And this would be your total mass. So your net force would be F1 plus F2. So now let's just go up here back to our givens and notice that this would be the same thing for your F2. It would be the same thing as saying negative 1,020 newtons to the right. So let's go ahead and plug it into the equation. Oh, I forgot. So your acceleration is equal to F1 is 970 newtons to the right minus 1,020 newtons to the right. So now they're in the same direction. Over what's your total mass? So 125 kilograms plus 98 kilograms plus 113 kilograms. And that comes out to negative 0.15 meters per second squared to the right. Okay, let's do another example. A passenger in a boat approaching a dock attempts to step onto the dock before the boat has been tied up. The passenger, whose mass is 57 kilograms, accelerates at a rate of 3.2 meters per second forward relative to the boat. If the mass of the boat is 97 kilograms, what is the acceleration of the boat relative to the passenger? Neglect the horizontal force of the water on the boat. So let's write down our givens. So P is your passenger, B is your boat. Let's draw a free body diagram. Where's my awesome color? I'm not going to actually draw a boat. So this is your force of your passenger. And using Newton's third law, this is going to be the negative force of your passenger, which is equal to the force of the boat, because every action force has an equal and opposite reaction force. Okay, so now let's set up our equation. So we know that the force of the passenger is equal to the mass of the passenger times the acceleration of the passenger. And so let's sub in our values. So we have 57 kilograms times 3.2 meters per second squared forward. I don't have room, but I mean to write forward. And that gives us 182.4 newtons forward. So using Newton's third law, we know that the force of the boat is equal to the negative force of the person, which is going to give us negative 182.4 newtons forward. Or we could have just said 182.4 newtons backwards. So now we have your force of the boat. To figure that out, we're going to use mass of the boat times acceleration. And you want to isolate for your acceleration because that's what we want to find. So your acceleration of the boat is going to be equal to your force over your mass. And now we have those values, so your force of your boat is going to be negative 182.4 newtons forward over, what was the mass of the boat, 97. And so it's going to come out to negative 1.88 meters per second squared forward. So therefore, the acceleration of the boat would be negative 1.88 meters per second squared forward.